Chapter 6, Section 3 is about solving systems of equations using elimination. And in this section, we're going to talk specifically about problems that have the same coefficient in front of your variables. Now remember that a coefficient would be the number that sits in front of the letter in the problem. So if there's a 2x in a problem, 2 would be considered the coefficient because it sits in front of the variable. When we're using elimination, this works by getting those coefficients to be opposite. So we want to be able to get opposite coefficients. In order for us to easily eliminate the variable. So what that is going to look like is you're going to have two equations like we've seen in previous sections. We're going to try to get our matching variables that have the same coefficient to be like lined up on top of each other so that we can try to eliminate them. So if we need to, there will be times where our coefficients aren't necessarily the same, and so there might be times that we have to get them to be the same before we can do this. But today we're only going to focus on the ones that do have the same coefficient in the front. And so these are the steps that I want you to follow when you're doing these problems. Step 1 is to choose a variable that you want to eliminate. When we did substitution, I had said I didn't care if you solved for x or if you solved for y on an equation. You just needed to do whatever would be easiest. Same goes here. It doesn't really matter which letter you want to try to eliminate. You just have to look at the problem and decide which one you think would be easier to get rid of. So choose whichever variable is easiest to eliminate. Then you want to make sure that you have opposite coefficients in your equations. Opposite means that one of them needs to be positive, one of them needs to be negative, but you have to have the same number sitting in the front. Once you have opposite coefficients, you're going to add the equations together, and then you're going to be able to solve for the remaining variable. Once we've done that, we're going to kind of go back and do what we did with substitution. We're going to plug the value of our one variable of those equations that we found and solve for the other variable. And then we can also still check our answer like we did with substitution. So let's take a look at this first example here. So I have 2x plus 3y equals 13, and I have 4x minus 3y equals 17. I want you to notice the y coefficients. So the ones I just highlighted there. Y has coefficients of 3 and negative 3. If I were to add these equations together, those y terms are going to eliminate because they're opposite coefficients here. Then I'm going to add the other pieces together. So 2x plus 4x would be 6x, and 13 plus 17 would be 30. And that's actually what I'm going to bring down here. 6x equals 30. Now what I want to do is solve for x, and I'm going to do that by dividing by the 6. And so I get x equals 5. So now what I'm going to do is take my 5, because I found x, I'm going to plug it back into one of those original equations up top in order for me to find my y. So I'm just going to go back to the top equation. So that one says 2x, but instead of x, I'm going to put in a 5 in parentheses, plus 3y equals 13. So now I have 10 plus 3y equals 13. Subtract the 10. And so I have 3y equals 3. And then we divide by 3 on both sides, and we get y equals 1. Now again, I've got my two variables solved for here. And just like when we were graphing and just like when we were doing substitution, we want to write this as an ordered pair. So we put the x first and then the y. So it'd be 5, 1. So I want you guys to take a look at this practice problem underneath here, and I want you to try to do this one yourself. So pause your video here, do this problem, and then keep watching to see how it should have worked out. So for this one, I noticed that my x's are actually opposite of each other. I have negative 3x and positive 3x. So I'm going to go ahead and add these equations. My x's are going to cancel, and I have 4y plus negative 6y. So that should be negative 2y. Bring down the equal sign. 12 plus 18 is 30. Then we're going to divide by that negative 2. And so I have y equals negative 15. So there's your y. Now I'm going to take that and plug it back in to one of those equations up above. Again, it doesn't matter which one you go back into. I'm just going to use the top one. So I have negative 3x plus 4, and in for y, I'm going to put that negative 15, and then equals 12. So I have negative 3x minus 60 equals 12. Then I should have added the 60 over. And so I have negative 3x equals 72. Then I divide by negative 3 on both sides. And so I got x equaled negative 24. The last thing we should do is write this as an ordered pair. So that should be negative 24, negative 15. Now, on this next example, when I get started, I see that my y's have the same coefficient because they both have 1's in front, but they're not opposite. So an easy way to create opposite coefficients is to just multiply one of your equations by negative 1. So what I'm going to do is take this top equation and I'm going to multiply by a negative 1. And so what that now is going to say is negative x minus y equals positive 7. You have to take that negative 1 times every single term in that example. That way it stays balanced and we didn't really mess with the integrity of that equation at all. Now I'm going to bring down that second equation, so 3x plus y equals negative 9. Now I have opposite coefficients, so I can add like I had been doing earlier. My y's are going to cancel. I'm going to bring down these remaining terms. So negative x plus 3x would be a 2x equals 7 plus negative 9 would be negative 2. And then we're going to divide by 2. So we get x equals negative 1. And now, following my steps here, I'm going to go back and solve the equation for y now. So I'm going to take that negative 1, come back up to one of my original equations and plug it in. I'm just going to go back to that very top equation, that x plus y equals negative 7. So I've got negative 1 in for the x plus y equals negative 7. Then I need to add 1 over to get y by itself. So that's going to be y equals negative 6. And the last thing, just like we were doing earlier, is to write our final answer as an ordered pair. They always go in alphabetical order, so x goes first and then the y. So for this practice problem, I would suggest that you make the y's become opposites of each other because they already have the same coefficient. So choose which equation you want to multiply by negative 1. And then I want you guys to take a few minutes and try to do this problem on your own. So pause here, try it out, and then come back and keep watching. I just took the top equation times negative 1. So now it says negative 6x plus 3y equals negative 27. I brought down the second equation because I'm not going to change anything about that one. I'm going to add my two equations together here. The y's are gone, and I'm left with negative 4x equals negative 16. Then I divide it by a negative 4. And so I get x equals 4. Then I take that and I plug it back into the beginning. I went ahead this time and I used the bottom equation just because I do think I don't know, it looks a little bit easier because the numbers are smaller, I guess. So I'm going to put 2 instead of x, I'm going to put a 4 in. Minus 3y equals 11. So I have 8 minus 3y equals 11. And subtract the 8. So I get negative 3y. 11 minus 8 would be 3. I divide by negative 3. And so I have y equals negative 1. So then again, my final answer as an ordered pair should have been 4, comma, negative 1.